Alright, here's our video for lesson 6.4 about rectangles, and this is going to be fairly short, and so we'll get going right away. If you haven't done the warm-up yet, go ahead and do that, and you should be able to find these things about this picture here. It is a parallelogram. You should be able to find the length of CD and find the measure of angle C using this information because you know it's a parallelogram. So do that warm-up, and then I'll show you what the answers should be. Okay, if you need more time, pause the video. Otherwise, this is what you should get. Okay, because we have a parallelogram ABCD, opposite sides are congruent. That means 5y equals 2y plus 8. When you solve for y, you get 3. And to define CD, we plug that back into this expression for CD, and we get 14. Then to find the measure of angle C, we need to remember that consecutive angles of a parallelogram are supplementary. So I can write this equation, solve it for x, and get 5. And then you'll also need to remember that the measure of angle C should be equal to the measure of angle A because they're opposite angles. So I can plug 5 in for x here and get 104 degrees for both angles A and C. So your answer for part number 2 is 104 degrees. All right, we're going to talk about rectangles here. The first type of special quadrilateral that we learned about is a parallelogram. And that is a quadrilateral where both pairs of opposite sides are parallel. And then the second type of special quadrilateral we're going to look at today is a rectangle. And that is actually a special form of parallelogram. Rectangles are in fact parallelograms because their opposite sides are parallel and congruent, as well as any other criteria for a parallelogram. A rectangle meets that. So a rectangle is a parallelogram, or for that matter, we could just call it a quadrilateral, with 4 right angles. Okay, so there's two main properties of rectangles. Okay, first of all, a rectangle has 4 right angles. So if it's a parallelogram, it has 4 right angles. Also, in a rectangle, the diagonals are congruent. So if it's a rectangle, it has congruent diagonals. And those are the main facts I wanted you to get for that. Now, remember this, since a rectangle is a special type of parallelogram, it inherits all the properties of parallelograms that we learned back in lesson 6.2. So all the things that were true about parallelograms are still true for rectangles also. Okay, so let's go ahead and take a look at using these properties of rectangles to find some measures. So in part A, we are given that JKLM is a rectangular picture frame, so it's a rectangle. And we know that JK is 50 centimeters. And JL, this diagonal, is 86 centimeters. We want to find HM and LM. Now, LM's the easy one. Since a rectangle is also a parallelogram, opposite sides are congruent. So I can go ahead and say LM equals 50. Remember that in a parallelogram, diagonals are congruent to each other. So HM is half of the diagonal. It's also going to be half of the other diagonal. Since diagonals bisect each other because it's a parallelogram and they're congruent, KM equals JL. So KM equals 86 because we know JL is 86. But HM is 1/2 of KM. Therefore, it's 1/2 of 86, which becomes 43 for the length of HM. I'm sorry, you couldn't see that part. There you go. All right. For part B, we are told that EFGH is a rectangle. We're told that GH is 6 feet, and FH, the diagonal, is 15 feet. We need to find GJ and FE. This is going to be very similar to example 1A. I want you guys to go ahead and find those two things. Find GJ and FE. Alright, if you need more time, pause the video. Otherwise, this is what we should get. GJ is half of one diagonal, GE. Now, since it's a rectangle, the diagonals are congruent, so half of GE is going to be the same as half of FH. And FH is 15, so I just substitute it again, and half of 15 is 7.5 feet, or 7.5 feet. Then FE is the opposite side from GH, and opposite sides are congruent, so FE is also 6 feet. Okay, so we've got another example here. We're given a quadrilateral RSTU, and it is a rectangle. We know that for a fact. And so what we can do is we can use what we know about rectangles to find the angle measures here, or find the value of x rather, using the angle measures. So we're told this, that angle RTU, so this angle, is 8x plus 4. And we're told that angle SUR, this angle, is 3x minus 2. Now we have to find a way that these angles are related. Now I'm going to show you something. Okay, if I draw this diagonal connected to this side of the rectangle and then connect that to the bottom side of the rectangle, you'll remember that in a rectangle there are 4 right angles. And so if I show you that, you should notice that's a right triangle. Okay, and so what we have here is that this angle, 8x plus 4, is actually one angle of that right triangle. Now, if I were to draw in the other diagonal, see if we can visualize this overlapping, and draw this side and connect it to the bottom, we have overlapping right triangles that should be the exact same measure. Okay, because the diagonals are congruent, that means the hypotenuses of each of those triangles are congruent, and they share this leg, so triangles could be congruent by HL. That means that this angle is the acute angle of a triangle, and this angle is another acute angle of a triangle, and it's also 8x plus 4. Since this is a 90-degree angle, remember that the two acute angles of a triangle are complementary, meaning they add up to 90. So the equation we can actually write is that 3x minus 2 plus 8x plus 4 equals 90. These two angles should be complementary. They should add up to 90. And so we combine our like terms. 3x and 8x is 11x. Minus 2 and plus 4 is plus 2. Subtract 2 from both sides. Divide by 11. And x equals 8. And that is all we were supposed to find. Okay. All right, now we also have conditions for a rectangle, or conditions for rectangles, and there's really two main things I want us to focus on here. And these are going to be if-then statements. Remember that if-then statements are conditional statements. And the first is, if a parallelogram has one right angle, then it is a rectangle. Because if it has one right angle and it's a parallelogram, then the opposite angles are both right angles and the consecutive angles are also both right angles, making all 4 right angles, which makes it a rectangle. And the last one is that if a parallelogram has diagonals that are congruent, then it is a rectangle. Okay, so if we have a parallelogram given to us and we know the diagonals are congruent, then we can say it's a rectangle. All right, so we're going to do this last example, and using our coordinate geometry here, we are given a quadrilateral, and they go ahead and graph it for you. And it has these vertices. We want to determine whether or not it's a rectangle using the diagonals. We're also going to verify that the angles are right angles. So here's how we're going to do that. Step one is to verify that it is a parallelogram. In order to do that, we are going to look at the diagonals. Okay, that's what we're supposed to be focusing on. All right, in order to verify that it's a parallelogram using the diagonals, remember that the diagonals bisect each other. All right, and that means that the diagonals are going to have the same midpoint. So what I want us to do is to find the midpoint of JL and the midpoint of MK or KM. Okay, and here's your midpoint formula again. Okay, so we're using JL and KM. So we're going to find the midpoint. And I'm going to let you try and do that one on your own, so pause the video, and then we're going to see what that should be. All right, here's what we should get for the midpoint of JL. All right, for the midpoint of JL, we get 1/2, 1/2. And then this is what we should get for the midpoint of KM. Also 1/2, 1/2. Since the two diagonals have the same midpoint, diagonals bisect each other. Okay, that means it's a parallelogram. All right, so we have shown that it's a parallelogram in step one. Step two is to verify the lengths of the diagonals are congruent. So we're going to use our distance formula for step two. Okay, we're going to find the length of JL and the length of KM using our distance formula, which is this. Okay, and so we're going to use our distance formula to find the length of JL. Three plus 2 is 5. 5 squared is 25. Negative 2 minus 3 is negative 5. Negative 5 squared is again 25. So we get the square root of 50 for JL. We're going to do the same thing for KM. 1 minus 0 squared plus 4 plus 3 squared, which 1 minus 0 is 1. 1 squared is 1. 4 plus 3 is 7. 7 squared is 49. 1 plus 49 is 50. So both JL and KM equal the square root of 50. So we can say that the diagonals are congruent. Therefore, the parallelogram is a rectangle. All right. And now we also want to verify the angles are right angles, so we're going to verify the sides are perpendicular, and to do that we're going to use their slopes. And remember that if lines are perpendicular, they have opposite reciprocal slopes. So step 3 is to use the slope formula for the sides LM and KJ should be the same. And then also for JM and KL. So we're going to use slope for the two parallel sides here, the two parallel sides there. Now remember, slope is just rise over run. You can do the y2 minus y1 over x2 minus x1, but since they give you the graph, all we have to do is count the slope. So these sides JK and ML or LM go up 1 over 3. So JK or KJ and LM have a slope of 1/3. And then these longer sides, JM and KL, go down 1, 2, 3, 4, 5, 6 to the right 2. So that is negative 6 over 2, which simplifies to negative 3 over 1. Negative 3 over 1 and 1/3 are opposite reciprocals. That means that the sides, or consecutive sides, are perpendicular, which means there are 4 right angles. All right. So to show that sides are perpendicular, use the slope formula. And to show the rest, we use these formulas.